Welcome to your first lesson of our new topic, Bake It. Miss Mayhew, Mrs. Wolsey and I are all very sad that we can't be together for our Discovery Day. But hopefully today's lesson will give you a little bit of an introduction to the topic, revise some of the science objectives that you will have looked at before, and start off a really exciting topic. We will be doing some science experiments through our Zoom lessons and through other videos throughout the term. Today we are going to do our knowledge harvest and some revision about states of matter. Our topic will be focusing on the science of cooking. So you might be thinking, what on earth has cooking got to do with science? But it actually involves many different scientific processes, changing and separating materials, combining, dissolving, heating and cooling, and all of this can create chemical and physical changes. There is lots of chemistry involved with cooking. For your knowledge harvest, you can either use the template that was in the home learning pack or you can create your own. I want you to think, what do you already know about baking and cooking and the science behind it? I've put some vocabulary on the screen here, which might help you remember what you've done in the past about different materials and how they change during baking and cooking. Think back to your chocolate topic in Year 4. So some of these might spark some ideas. I would like you please to write at least 5 bullet points for what I know and then at least 5 questions for what you want to know. Obviously you may do many more than that. Pause the video while you complete your knowledge harvest for this topic. It's really important that you understand the 3 different states of matter. Can you remember what they are? The 3 different states of matter are solid, liquid and gas. Can you explain to somebody around you what is the difference between these states of matter? Do you know how you could make one state of matter change to another? Can you give an example of a solid, an example of a liquid, or an example of a gas and how this changes? And do you know if this change is reversible? Just discuss with someone or something around you what you already know. Here are some examples of how materials change state through cooking. For example, when you bake a cake, you normally begin with a liquid mixture. Think about cake batter. And by heating it in the oven, it becomes a solid. Think about making a cup of tea. You combine 2 liquids, milk and water, and you dissolve solid sugar into a liquid. When you're boiling the water, some of that turns into water vapour. Think about an egg as well. When you crack a raw egg, inside it is liquid. But when we eat it, either in omelette form, as a boiled egg, scrambled egg, or fried, it becomes solid. Can you think of any other transformations? Everything we see around us is made up of matter. Matter is made up of teeny tiny particles, which are called atoms. The atoms are really important in determining whether something is a solid, a liquid, or a gas. The way that the atoms are arranged makes it a solid, liquid, or gas. What do you notice about the particles in a solid, a liquid, and a gas? Hopefully you can see that in a solid, they are all very compact, very close together. They have a fixed shape and they have a fixed volume. So think about a pencil, think about a cup. Obviously you can break them, but you can't move them into different shapes. They are what we'd call solid. In a liquid, the particles are slightly more spread out and have a little bit more room to move. They don't have a fixed shape. If you imagine a jug of water, you could pour it into a really tall, thin glass or quite a wide, short glass. And the liquid will take the shape of whatever it is you've poured it into. It does, however, have a fixed volume. If you start with 100 millilitres of water and you move it into another cup, for example, it will still have 100 millilitres of water. In a gas, the particles are further apart and they move around and bounce off each other much more. There isn't a fixed shape and there isn't a fixed volume. Pause the video now and read out the information about solids. Now pause the video and read the information about liquids. Finally, pause the video and read the information about gas out loud. Ice, water and steam are the most commonly used example. There is no chemical difference between these substances, but it's how their particles are arranged that makes them really different. In ice, the particles are rigid and close together. In water, they have a little bit more space to move around, and then in gas, they are much more free. We use temperature to change the state of water, and we can do this with other materials as well. For example, solid iron can be turned into a liquid. Your first task today is to create a revision poster about different states of matter. I know that there's somebody in my class who might be excited by what's on the board at the moment. You might want to think creatively and think about how you can represent the particles in solids, liquids and gases. There's an example here using Cheerios on the board. You have got to create a poster that makes sense for you. I would like to see a visual representation of a solid, liquid and a gas, and some explanation of what makes them different. You might want to include examples. Some of you might want to go a bit further and explain how states of matter change from one to another, if you already know this. You might want to look back to the previous slides to help you make your poster. And again, I'd like you to think creatively. Pause the video while you complete this task. Please remember to take a photo of your poster and upload it to Padlet. Here is your next activity. This shouldn't take you too long. In your book, you can write the headings solid, liquid and gas. And I want you to write the examples in which column you think they would go in. Some of them are tricky. I've put them in there to challenge you. Pause the video while you do this task. Here are the answers. Were you correct? Now I've put toothpaste in between solid and liquid. This was probably one of the ones that was there to test you. Toothpaste is a mixture of liquids and solids because it includes some powders. So lots of scientists argue that it's a mixture between a solid and a liquid. Things like sand and flour, even though you could imagine pouring them from a jug, they are still solid because their individual grains are solid. Again, something like cotton wool, even though we wouldn't describe it as hard or tough, it isn't a liquid because it doesn't flow, so it has to be a solid. An interesting question for you. What is the difference in the mass of the balloon here before it's blown up and then when it is blown up? Has the mass gone up or down? Or, as you will probably understand it, is the balloon heavier or lighter? Pause the video while you discuss your ideas. When asked this question, lots of children said that because they know that gases are light, they think the balloon becomes lighter when it is filled with air. But air is made of matter, and therefore it must have mass. So if you think about filling the balloon with water, you would probably all say that the balloon would be heavier. So although air doesn't make the balloon as heavier as water would, it still does make it a little bit heavier. If you had some very accurate scales, you could prove this by measuring it. Your final task today can be found in your home learning pack, or you can have a go at drawing it out yourself in your book. There is a states of matter crossword, and the missing words from the sentences are in the box below, and then you can fill them into the crossword. There's also an optional extend task on the next slide. If you would like to learn more about states of matter, you can go on the BBC Bite Size website following the link here. There is a video to watch, there's information to read, and you can complete the interactive activity and take the quiz. I hope you enjoyed today's lesson. Your next topic lesson will be on Zoom, and it's going to be really quite fun. See you then!